system. I'm going to let the microphone and the stage to Shuoqi Yu.
Hello, everyone. I'm Shuoqi Yu from openKylin's. It's my great honor to be here to present our work on openKylin's and the software and the Kaiming software package format. Next, I will share from the following experts, which are part 1, current landscape and changes, part 2, the exploration of the Kaiming software package format on openKylin's, and part 3, a look and roadmap. So I will first introduce the openKylin's, and then I will introduce the Kaiming software package format. Part 1, current landscape and challenges. Here are several evolutions of traditional package formats. They are DEB, RPM, and package build. Firstly, the band-based system, they rely on DEB. In 2025, it has improved dependency resolution algorithms to reduce installation failures from package conflicts. What's more, some DEB packages now manage file snap. Second is the Red Hat-based system. They rely on RPM format. In 2025, GNOME Software Center may phase out RPM support in favor of Flatpak. Finally, the Arch Linux-based system, they rely on pack build. It continues running release model with ongoing updates and maintenance for package build-based packages. Here are some development of emerging package formats. They are Flatpak, Snap, and ApeImage. Firstly, Flatpak in 2024, it has added support for VLAN security context protocol, and which is enhancing sandbox security and compatibilities. What's more, FlatHub downloads support 2 billion, flagship growing user adoption. That's really remarkable. Second is Snap. In 2024, ongoing improvements to starter up speed and overall performance with notable progress in desktop application responsiveness, and it has improved auto-update mechanism with Delta updates to reduce bandwidth usage. The finally is ApeImage. In 2024, major upgrades to ApeImage Kit occurred, and it has enhanced efficiency in dependency resolution and packaging workflow. There are several challenges between package formats. They are compatibility, reliability, and security. Firstly, we will focus on compatibility. Complex dependency applications often rely heavily on system libraries, which are blurring the line between apps and the systems. Second is reliability. Poorly packaged apps can affect overall system stability due to unclear system and application boundaries. Finally, security. Security contains malicious code in apps, can access private data, and revealing weak security isolation. Part 2. Let's focus on the exploration of the Kaiming software package format on openKylin. So, what is openKylin? openKylin is an open source project by the OpenAtom Foundation, and it aims to provide an AI integrated open source operating system. It has 9 versions, and it supports 2 million users and beyond 15,000 developers. openKylin launched Loma, the world's first RISC-V laptop, and has introduced an AI subsystem with tools like an AI framework installer, intelligent voice assistant, and LLM-powered plugins. Just like Michael just talk. And it collaborates with large model partners, including Intel and iFly Tech, building the AI PC software and hardware. What's more, openKylin has been featured by major media outlets, including CCTV in China, the Register, and South China Morning Post, and Tom's Hardware. openKylin has several multifunctional features. It has over 108 core system components, and the immutable system architecture built using OSH technology, and it reinvents the file system, booster process, and version management. It also supports several architectures, which is x86 and ARM64 and RISC-V long arch. The welcome compository provides essential display functions. We also have AI integration. It fully supports Intel's latest MTL AI PC platform. What is important is that UK UI desktop environment, the same as KDE and GNOME. It has optimized 6 core models. It has framework and lightweight UI design. It fully designed architecture allows faster updates, high customer and strong scalability. The last, we will talk about Kaiming software package format, which it means to build once and run anywhere, just like Flatpak and Snap and Apple Image. It has enhanced security and compatibility. So, what is Kaiming software package format? It's a new packaging solution by the openKylin community decided to this purpose. It clearly separates system and application layers and to reduce fragmentation across Linux distributions, and it could enhance compatibility and simplify app deployment. What's more, it supports large-scale management of existing Linux apps. It could streamline installation and updates. The right picture is just about Kaiming. Kaiming has several key features. They are compatibility, security, what is important, and self-executable. For compatibility, applications remain functional even after system upgrades, ensuring long-term usability and security. It supports multiple information management mechanisms to safeguard user privacy and data. The right picture is about Kaiming Package offline structure. We can see that the matter section is just about the Kaiming application information, and the boundary section is an scratch FS file systems. So it could make a Kaiming is self-executable, just like app image. So we could run directly without installation. We have two core technologies behind the Kaiming. They are OHQ, Kylin, and Kylin security. OHQ manages files via version-controlled modular RIPs, and it enables efficient incremental updates. What's more, Kylin leverages container tech for sandboxing, such as namespace and C group. It controls system calls and enforces file-ground permission rules. Yeah. See the next. Kaiming has a three-layer runtime architecture. We could see that we have three apps: UKUI apps, KDE apps, and GNOME apps. UKUI apps is based on runtime UKUI, and KDE apps is based on runtime KDE, and GNOME apps is based on runtime GNOME. This runtime is all based on one base. So thank you, Alex, and all of you for the efforts. Oh, thank you. And we will talk about overall architecture. The Kaiming could divide into three sides, which are client side, server side, and developer side. The client side installs runtime environment, and it runs application inside a sandbox. The server side is a package RIP. And in the future, we will support for security, scanning, and advanced controls. The developer side uses the same sandbox and runtime as the client. Source code is compiled in isolation. What's more, we could the build outputs are managed and synced via OHQ. So how do I punish our application to Kaiming package RIPs? That's a very simple process. First, we have the client side, and we could do client side to install, build, and toolchain environment. It contains shared libraries, and then we could build Kaiming applications. Finally, we could punish the Kaiming applications to Kaiming Package Rip, just like FatHub and Snapper Store. Let's take a further look at client side of Kaiming. It has three aspects: command parsing, Kaiming sandbox, and host system. The command parsing includes runtime parameter, application date, and sandbox parameters wrap. We could control resource sharing between Kaiming sandbox and host systems. Let's see the client-side Kaiming sandbox. There are several models of Kaiming sandbox. Kaiming application model includes components such as applications, runtime libraries, and lightweight system libraries, which is covering dynamic libraries and configuration file resources. Besides, namespace configuration model configures namespaces within the sandbox, such as mount, IPC, PID, and network, based on runtime parameters and or places. Next is C-run configuration model. It manages physical resources constraints within the sandbox. It configures CPU, memory, and I/O usage to ensure efficiency system resource utilization. We will see proxy agent model. Okay. This is our future demo video. Then I will show it. There are 4 technical processes currently. We have developed core models such as install, run, update. Besides, we have sandbox tool enhancement and application compatibility. We have also visualized build tool. We will provide a GUI-based workflow that FatPack not provide. Oh yeah. Part 3. The future of Kaiming. We will see from the force. In the future, we will build efficiency improvements. We will have cloud-based automated builder platform and speed up development and deliver of Kaiming pages, security enhancements. That is important. We will refine security policies and we will integrate CVE, scanning, and paging support. Yeah. We also have where ecosystem expansion. We will support multi-rips and private Kaiming Reaper deployment. We will support for XE with Windows and APK with Android applications. Yeah. Lastly, we will the performance and usability optimization. We will faster sandbox startup times and better resources utilization for apps running in sandbox environments. Thank you. I hope we will work together and you will learn from it, fundamentally. Okay.